change things. So, all right, absolute value. Here's what it is. So, absolute value is actually a distance. It's the distance from 0 on a number line. Because when we talk about distance, distance is always positive. Okay? If you walk to your friend's house and then walk back, you didn't go a net of 0. Okay? If you drive a car and you drive into Chicago and then you drive back, your odometer doesn't stay at the same number and go backwards when you're coming home. Okay? It keeps moving forward. So, absolute value kind of does the same thing. So if I ask you the absolute value of x equals 4, the question we're really asking is, what numbers, what mystery numbers here for x, are 4 away from 0? Now we're always going to think about 4. Does that make sense? I mean, shoot. I'm looking at 0, here's 4, that's 4 away. Are there any other numbers that are also 4 away? Negative 4. Bless you. Negative 4 is also 4 away. So my answers would be 4 and negative 4. Because when I take absolute value, whatever's in those bars comes out positive. No. Right. If it's just a number, you can just do it that way. Now, of course, it'll expand a little bit from that. But the number line's always an option for us if we want it. There's always going to be 2 solutions, though, unless the answer is 0. Then there's only 1. So here's the next thing we got to kind of keep in mind. What if I throw a twist at you already? Now, what if it's an equation in there instead of just x? Yeah, I'm going to split it into 2 equations. My first equation is always going to be just rewriting it without the bars. So notice the only difference between what I see in the problem and what I see here is that there's no absolute value bars anymore. We're going to take out the bars for the first equation that we do. Once we take the bars out, I'm going to go ahead and solve this. So what's my one step to get x by itself? Okay, add 6. So x equals 9. But that doesn't mean the other answer is negative 9. Because, you're like, dang. Because to do like what we did up here, because we talked about how this is 4 and negative 4, to get the equation so I get the right answer, notice what changes. What's inside the bars doesn't change. What's inside the bars doesn't change, but notice my positive 3 became a negative. So all I'm going to do is switch the sign of the number that I see over here, and then solve that equation. But here's the cool thing. What I do to solve the equation will be the same. I added 6 to solve. Okay, I'm going to do it here too. But what's negative 3 plus 6? 3. You're like, well, wait a minute. How's that work? Let's think about this for a second. If I were to plug 9 in here, 9 minus 6 is 3. Well, 3 equals 3. Okay, that makes sense. Well, what about when I plug in 3? 3 minus 6 is negative 3, but when it's in the bars, it always comes out positive. So since it was negative 3 in the bars, and it comes out, ooh, it's positive 3. It works. So that's what I'm basically doing right here below, and I should have written it in as I was saying it. What am I thinking? Again, the absolute value of 3 does equal 3. Okay, that's good. If I have 3 over here as my other answer, 3 minus 6, I agree, is negative 3. But once it comes out of the bars, it becomes positive. Yeah, okay, we're thinking, right, absolute value is about distance. And whenever we do distance, distance is always a positive thing. For instance, right now if I stood here and I took 3 steps, okay, I walked the distance of 3 steps. So if I turn around and I walk back the same 3 steps, did I go a distance of negative 3? No, I moved 3 steps forward. I did a total of 6 steps. So that's kind of what we're doing here. My biggest thing for some of you that get confused with this at the start, before you go into, I don't get this, I'm shutting down, just think about it this way. The only thing you have to remember is, when I'm doing an equation, my first equation, I just rewrite it. Yeah. And I don't have to do this every time. That's just me letting you see that's how it works. Okay? Because the only thing I have to do on my second equation is change the sign of the answer and then just solve it. So if I'm okay with one or two step equations, this really won't be that bad. Okay? Even though I like trying to explain to you where something's coming from. Thank you. So, when we get down to the bottom here, okay, solve each equation by showing work. Number one, sort of like the example at the very top. My first equation is just to remove the bars. Well, my second one, I'm just saying, because I'm showing there's two equations each time, is to change the sign of the answer. There's nothing to solve. I'm done. I wish they were all this way. They're not, but it'd be nice. I know. You should just make one. Especially on the test. Okay. Well, let's see. My first one, I just copy what's there. Let's set up the equations first, and then we'll solve them. So just copy. The second time, remember, the only thing that's different is that my answer becomes the negative of that. So in this case, it's going to equal -1. But I got to solve these, because A is not alone yet. What's my one step to get A alone in each of these? Minus the 2. And I'm going to do that in both equations. You mean why it's for two equations necessarily? Okay. Because when we're doing these, remember, when we were up at the very top, we talked about how when we talk about something, and I'll bring this back down in a second because I know some of you are jotting things down. We talked about how we always think what number is 4 away from 0. We think of 4, but we may not think of -4. We're doing distance still. Everything with absolute value is about distance. So that's why we have to do the two equations. Right. And we're just covering them both. Yep, we're just covering them both. So whenever I do these, again, first one, leave it alone, just lose the bars. Second one, change it to a negative. Yeah, it has everything to do with equations. It's just now figuring out how we're going to use them this time. And we are going to be expanding with this. We're going to be doing some things with inequalities and shading. But as long as we have the basics down, probably, let's see here, probably early, mid next week, we're going to get into the graphing business.
What if you don't have time? What are you going to do?
It's going to vary. They're still playing with some of the things. I haven't been given the exact curriculum yet. So as we flip, yep, I'll get it flipped back over here in a bit. We'll get you set. Now, over here, we're going to skip around a little bit because there's a couple of twists I want you to be aware of, but I don't want to go into overkill here. So, for instance, on number 4, not going to do a whole lot different. There's going to be one thing at the end, though, that I have to be careful of. And some of you are going to say, now, wait a minute. Notice, even though it was in parentheses, I didn't change the 5 minus x into 5 plus x. That doesn't change. Whatever's in the bars stays that way when I'm making my equation. Because what we end up doing here is, when we're talking about the distances, like back when we were on that first problem, we wanted to see how far it was in a positive direction, but we also wanted to see the distance in a negative. That's sort of what we're doing here. Because by looking at it from both sides, both the positive and the negative, I'm going to get both solutions that are this distance away from that particular number. So the only way I can get them both is by doing the positive and negative with my equation this way. Here's the thing that's a little bit fun with this one. When I go to solve for x, okay, how am I going to get the 5 out of there? Okay, we're going to minus the 5. Now, in every other problem we've done so far, at this point, we were done. But we have a little issue this time. We do, because now, right, there's a negative in front of my x. It's like a negative 1. So to get x alone, truly alone, I have to divide by negative 1. Because I don't want to know what negative 1x is. I want to know what 1x is. So basically, it's just going to change the sign. Because I have a negative in front of my x. It's not just one. So I got to divide by the negative 1 so I get that negative out of it. Because it's all about, flip that over. It's all about, absolute value is all about distance. So no matter what value we're starting at, there's always going to be two numbers that are an equal distance away from it. And over here we said, like, what's the value of x? So I had 4 and negative 4. Here, there's two values, yep, that are going to give me that distance that I'm looking for. In this case, they're 4 and 6. Because 5 minus 4 is 1. Absolute value of 1 is 1. But 5 minus 6 is negative 1. But again, it's distance, which will make it positive 1. So the only way I can get both answers is by splitting it that way. Yes, sir?
Well, pretty much, if you start in one spot, there's
Right, because I can go left to get there with an answer, and I can go right to get there with an answer. You only did half right. That's true. All right. Two more little things. I want to look at number 6, and then I want to look at one of the doozies down below. Same deal. Leave it alone the first time. Stay with me. We're almost there. Okay. Two-step equation. Only difference this time. Right. We got to get the t by itself first. So we got a minus 5 first. And I'm going to do that on both of these. That way I don't want to try to do something different. And right, my last step here, because there's a second step, is to divide by 2, because I need t by itself. Okay, and I get my two answers. The only other main twist that can get thrown at you on this is that my absolute value has to be by itself before I can split it. For example, we have number 9. Number 9, my absolute value isn't by itself right away. So I got one step I got to do before I start this problem, actually. Yep. So on number 9, before I can split it, okay, notice I haven't split this yet.
why does it
Right, this is what we just did. Okay, because now it looks like the other problems. The absolute value's on one side, my answer's on the other. Once it looks like all the rest of the problems have, then I can split it. So I still have my, just copy it down, and I still have where I turn this into a negative. And then we just solve them. Now, here's what we're going to do. If you finish the rest of the problems on this sheet, and I'm not going to tell you you have to do the challenge, so just up through 10. Well, I was going to say, and finishing up the rest of this sheet's extra credit. Because here's what we're going to do. I want you to keep hold of this while you're working on this assignment. But like I said, if you finish the others, not having to include number 11, that's a whole different story, you're going to get extra credit. What I am going to come with behind this is the actual work we're looking at. Now wait, it gets better. There's going to be 2 extra credit opportunities in one day. The assignment for the absolute value equations, and I'll put this up and I'll leave it up once we get going here. Okay, I'll write this at the top and I'll leave it. That even to the assignments, I know some of you need the extra credit. The odds are going to be extra credit. I want to show you one thing on this before I give it to you, because I actually want you focusing on me and not trying to work ahead on this. 2 little things here at the top. When it says evaluate each expression, you're just going to substitute and simplify. So for instance, if I'm doing number 1, again, this will still be here when we're done. Okay, the t-value is 3. So I just substitute t-value in. 8 minus 3 is 5. Okay, nope, not on this one. The absolute value of 5. Okay, so I'm just substituting, simplifying what's inside the bars, and then just adding and subtracting them up. Because here's the difference. When it just says evaluate and it's just giving me a number, I'm just doing that specific part and then I'm going to be done. Because I'm not trying to figure out what t is. They're telling me what it is. I'm just plugging it in. I'm not trying to solve it. When I get down here, though, I am doing the same thing. It's like, ooh, but we didn't graph before. Okay, but when you see how we graph, you're going to be like, oh, that's all it is? I'm like, yeah, you're going to die. So I'm still going to do them just like I did the other ones. Still going to solve for x, because now it says solve. But when I get my 2 answers, instead of just saying I'm done and going on to the next problem, I'm just going to put dots on the graph that's below it. Because that's how I show the answer on a number line. We're going to start working more with number lines here. That's really the only other thing that's different. Nothing else really complex. Nothing crazy. Okay? I'll leave this up that way, and I'll just kind of bump this down so you can see what we're up to. And so you've got your rest.